Behind me is the RRS Sir David Attenborough, a research ship dedicated to studying the ocean and glaciers. This boat is operated by the British Antarctic Survey, and we're going inside it right now.
Dude, this is kinda insane.
Aboard the ship is an international team collecting a range of different observations to understand how Greenland is melting, and more importantly, to try and understand how it's affecting our ocean currents and weather change in the UK and Europe. They only have 6 weeks to study how quickly the ice sheets are rapidly melting and pushing us towards a critical climate tipping point. This is Project Giant, presented to you by good old Gab. On board the ship, I got to talk to some of the crew and the researchers to learn more about the expedition and Giant.
Thank you so much for talking to me.
Thank you. My name is Matthew Neal. I'm the captain, or one of the captains of the Sir David Attenborough. I am in charge of the vessel. This ship is, so the Sir David Attenborough is a polar science and logistics vessel. So when we're in Antarctica, we do some logistics and some science. So the logistics is taking BAS people and other people down into Antarctic stations and then back up out of the Antarctic stations and then back onto places further north. And also we take their equipment and their waste out as well. So that's the logistics side of it. Then the science side of it is the ship would go away either in amongst these logistic cruises or their own dedicated science cruises like the one we're about to embark upon. So that could be up to 2 months away at sea at a time. And we're doing oceanography, whether it's biology or physical oceanography, etc., depending on the what the objective of the cruise is. Almost every science cruise that we've embarked upon has been something new, either for BAS or for this ship. So this one we're about to embark upon in Greenland is completely new for all of us. Most of the equipment on board hasn't been deployed off this vessel before, so that just shows that the vessel was well designed to look to the future and be very capable to be able to do cutting edge science for 25 years.
Could you show me what you do here in this space?
So generally this is what we call the conning position, so where I would drive the ship from, or the person who's driving the ship at the time would drive from. So the chair is lit up, and then you've got so these are the rudders, this is how you steer the ship.
Sick.
And this is how you speed up and slow down. This is your main engines. And you've got your chart, as you can see, so that's your electronic chart, but like your sat-nav, a bit more complicated than that. And then we've got a radar, so that shows us, it's not on at the minute, but it would show you an outline of all the landing ships that are around. So you'd sit here and you've got full control of the vessel.
And I got to talk to the overall project lead for Mission Giant, Dr. Kelly Hogan, a marine geophysicist at the British Antarctic Survey.
Sure. My name is Kelly Hogan. I work at the British Antarctic Survey. I'm a research scientist, and mostly I work on research ships like this one. And I actually use sound to be sent down either from the ship or from an underwater robot, and then it comes back to the ship, and I measure the shape of the seafloor, or in this project I actually measure the shape of ice faces.
Oh, interesting. So you use acoustics to basically look at shape underwater.
Exactly that. So like the sound will travel really well through the water, and then bounces back off something, and then we hear it back, and then we turn that time into distance, and then we get a shape in 3D as you move along on the ship. The RRS Sir David Attenborough is a polar research vessel, which means she travels to the Antarctic and the Arctic, and she makes observations of the ocean and the ice and the atmosphere in those places.
Amazing. Could you tell me more about all the overviews of the different research that you do here?
That's a big question.
Yeah, it's a really big question.
Yeah, I think that maybe one way to think about it is that the ship has lots of different instruments on her. So all the time we're measuring things like the temperature and salinity of the water. That can tell us things like where the heat in the ocean is approaching the polar regions, how that might melt the ice or turn into iceberg carving. Then we also can deploy loads of different vehicles from the Sir David Attenborough. So we have a small workboat that we can put in, and then she can go even closer to the ice than we might be able to go on the big ship. And then she can also launch marine robots from her, which can go even closer to the ice. So we have the big ship as a sort of parent ship, and then we have sort of children going off and doing their things. We also have an amazing heli deck on the front of the ship, and we'll have a helicopter come and join us in Greenland that will take people ashore. They'll be measuring things on the ice itself, but we'll also use the heli deck to launch drones, 2 different kinds of drones.
That's sick. That's so cool.
It's so cool because they can they can fly over the ice and map the front of the ice in a way that we can't do from the ship. We do everything under the water from the ship, and the drones will look at the stuff from the air.
Amazing. And why do you want to do that?
We want to do that because as our climate is changing and getting warmer, the polar regions are changing very quickly. And what happens in the polar regions affects the rest of the planet because it impacts the ocean currents, it impacts how much carbon dioxide can be taken down by the ocean, it impacts the biology that live in the ocean. So what happens at the poles affects the whole planet, so we need to study that.
After chatting with Dr. Kelly Hogan, we got the chance to see the machines up close and personal.
Are we allowed to come closer? Yeah.
Hi everyone.
Hey.
Hi.
My name's Yoram. I'm a glaciologist. I primarily work with seismics, like seismic data collected on glaciers, and use that to kind of assess what the dynamics of the ice are.
I am Martim. I'm also a glaciologist, and I work on combining data that we get on the field with numerical models, so simulations of how the ice responds to different climate.
Hi, and I'm Ollie. I'm also a glaciologist. Most of my work uses GNSS and GPS for like precise velocity and strain tracking of glaciers. So we're interested in how the warming ocean kind of erodes underneath the front of the glacier, which kind of creates overhangs, and then bits of ice fall off. Those bits of ice can disrupt the ocean circulation and currents and then create more melting. So there's this complicated feedback between the melting process and the fracture and iceberg forming process. And that's really what we're trying to understand here, is that kind of link between the two and how one can enhance the other, or like one feeds back into the other.
Can you guys just show me what is happening here on this helipad? What's happening everywhere?
On this side, this is an antenna for a GNSS receiver. The receiver's in the box at the back there and is powered by a solar panel, and it's got a battery system and a regulator, and there's various complicated electronics in the box. And then next to that there's a time-lapse camera, and this is for kind of just looking at the ice front. So whenever we see pieces falling off, we can then correlate that with what's happening in the other data sets.
So this is a bit of a different drone than what most people are used to seeing, because it has fixed wings. It's not like one of those quadcopters. Still, it can take off vertically, and then as soon as it reaches a certain height, it will go horizontal and then fly like an airplane. And the advantage of that is that it's very battery efficient, so the battery doesn't drain as fast as the other drones we're used to, meaning we can cover a very large area of the glacier with it and taking pictures of it. And with these pictures we can get all different types of data. We can try to come up with the shape of the glacier, the elevation of it. We can measure the speed of the ice as well if we compare different images. We will try to measure as well how fast these cracks on the ice open and close as well, which we can link up with everything else that Ollie and Yoram are going to talk about.
Over here we have a range of seismometers. So we have this one that is quite fancy. This one can measure very slow motions of the ground as well as fairly fast motions of the ground. We're going to deploy 4 of those. Then we have these that are a little bit cheaper, a little bit easier and quicker to deploy, and we're going to use 20 of those across the glacier to get a really high resolution picture of what is happening on the ice. And then finally we have these, which we've designed internally ourselves, and these are kind of even easier to deploy. They're really just one button and they can go. And we're also going to put 20 of those across the glacier. Those measure motion of the ground and also their position on the glacier, so we can get a really good picture of what's happening.
And the tech didn't stop there. A couple floors below, we got to see the robots that were going underwater. This is the Gavia Autonomous Underwater Vehicle, a torpedo-shaped robot that'll get face-to-face with the ice. It'll dive down to 500 meters and use a multi-beam sonar to gather ocean data. And this is my favorite sub, Boaty McBoatface, an auto-sub long-range that will be deployed to probe beneath Tidewater Glacier melange to assess its geometry, its shape, and influence on glacier behavior. All of these robots are here to collect data that they can use to feed into models to predict what's going to be happening to the ice sheets. Greenland is the world's largest island, and roughly 80% of the country is covered by ice sheets that extends 3 kilometers in thickness in some places. The volume of the glacial ice is estimated to be 2.9 million cubic kilometers. That's enough frozen water to raise global sea levels by more than 7 meters if fully melted.
This is just one model simulation.
This is the water that's potentially coming out of underneath the glacier.
Yeah.
And this is the mixing that's happening there, right?
Yeah, that's right. So this is showing all sorts of different things. Well, this one here is the temperature, for example.
Okay.
And what we're doing here is releasing this relatively cold water, so it's blue. We're releasing it from beneath the glacier, and then the fjord is quite warm, so it's kind of yellow. So you can see that as this water is also like fresh, and because it's fresh, it wants to rise. It's relatively light, so it wants to rise up, and so it forms this really vigorous, really turbulent rising. This is a rising current of ocean, right? And you can see that it's mixing warm water towards the glacier, right? So the water starts cold and it gets hot up here.
Right.
And so because that's so vigorous, it's mixing the warm water in from the fjord towards the ice. Every time it brings some warm water towards the ice, that's going to cause more melting. So the more that is kind of boiling around and mixing, the faster the glacier is going to melt.
Current large-scale climate models either omit or misrepresent the complex physics of glacier melting in Greenland's deep, narrow fjords, which is why all this data and this modeling is important. But there is another way we can use this data.
This is our current design for an early warning system.
Okay.
So we're already running ice sheet models, right? So we can set up and run an ice sheet model that will produce a 100-year forecast of a particular glacier. So what we're going to do is, with these lines, we're going to, every month or so, we'll have a new satellite image where we'll know where the ice front is. We set up a new model, we run it. If we see the ice front move back and we see the glacier speed increase, then we know something happened in that month that was unusually bad, right?
Oh, and then you can kind of see what influenced that increase.
Yeah, that's right. Yeah. By running a succession of forecasts, if our forecast suddenly gets worse, then we'll look back at that month and say, what was it that changed? Some kind of tipping has happened in this glacier. What was it? We can learn about it. And then hopefully we'll get to the point where we can warn about future changes from that learning process.
This project aims to capture the complexity of melting ice in Greenland's fjord glaciers, and also develop an early warning system to detect impending major shifts in glacier behavior. This research highlights the fragility of Earth's frozen environments and what that means for the health of our planet.